All right, so just talked to you recently about our first type of element, our binary ionic compounds, so very simple ones using these guys and these guys. Sorry, I had to sneeze and it's not coming out. Now I want to talk to you about this middle portion called transition metals. So these are called binary ionic compounds containing a transitional metal. So if we go here and we look at these transitional charges, the most important part from your periodic table is that you need to know that the charges can change. Their oxidation numbers can change. So these guys all in here, they could have a +1 charge, they could have a +2 charge, they could have a +3 charge. Some of these guys could even go 4 or 5 or 6 or 7 or 8 charges. So there's a thing that chemists need to know. We need to be able to communicate what the charge is. And we can do that through adding Roman numerals. Now, the hardest part about doing this is oftentimes people forget that these guys in the middle, and including tin and lead over here off to the side, need Roman numerals. So, sorry. So this is very similar to what we just did in the previous video, except that we need to include a Roman numeral. Okay, so let's say we are going to take, I don't know, this one. Let's take cobalt. Okay, cobalt's right here. So we're going to take cobalt. So I'm going to take cobalt. And I'm going to give cobalt a +3 charge. Okay, cobalt could also be a +2 charge. We could even have a cobalt with a +4 charge. Okay, so just so you know, any of those ones that are kind of colored in the orange section can change. It's really important that we know and be able to communicate what that charge is, because it can have a whole nother set of properties and characteristics and whatnot. Okay, so we are going to combine those with these guys over here. Okay, we're going to combine them with these guys over here. These are our non-metals. Okay, and we're just going to pick any one and combine it with that. Okay, so let's do that. Let's pick nitrogen. Okay, so we go up here and we scroll up and we know that nitrogen is always going to have a -3. Whereas cobalt here, if we scroll up, there's no charges here because their charges can change. Okay, so we'll put this with nitrogen. So we'll bond all these with nitrogen. So nitrogen, 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 every single one of them will all be a -3. Okay, all right. So now we would crisscross charges like always, right? This 3 would want to come down here, and this 3 would want to, oops, and this 3 would want to hold on, move these guys down a little bit. And this 3 would want to come over here. Okay, so I crisscross charges, right? But when the charges are opposites of one another, meaning a +2 and a -2, direct opposites of one another, they cancel. Just like in this case, you have a +3 and a -3. They cancel. So we get rid of them when they cancel. They just go away, okay? And they get, the formula gets mushed together. Capital C, lowercase o, that's important, and then uppercase N. So CON is the name. Now, if we go to name this, we still need to write the charge in there, okay? We still need to have that charge. So we can go like this. I still know that the charge was a +3. Even though I cancel the charge, I still need to write the charge. So I still know that this is cobalt. Oops, CO. cobalt. And I need that Roman numeral 3 in there. And why? Because this charge has to match the Roman numeral. Okay. And then I would move on and I would say nitrogen. But we know all of these elements get the ending changed to IDE. So it's not going to be nitrogen, it's going to be nitride. So cobalt 3 nitride. And then again, we know that the +3 and the -3 cancel. Okay, the +3 and the -3 cancel. Hold on. Okay, sorry, I paused recording because all of a sudden my screen sharing stopped. So those charges canceled, and then these two get mushed together. Okay, so there you go. That's the next one. All right, now let's move this guy down here. All right, now we got crisscross charges, right? So I'm going to bring this 2 over here. I'm going to bring this 3 over here. That's crisscrossing charges. Now I get rid of the plus and the minus because you don't have like a negative subscript or a positive subscript. And then you mush them together. Oops. And then you mush them together. So there's my formula. Okay, with a 2 and a 3. And now I got to write the name. So we know that CO is cobalt. And I know that the charge on cobalt used to be, this 2 used to be up here as the charge, right? That 2 came down here from the charge of cobalt. Okay, so I now can say that it's a Roman numeral 2, and then nitrogen. And because, again, this area of the periodic table, if it's any of these blue ones, they get the ending changed to, and I'm actually going to erase this, they get the ending changed to IDE. So there you go. You have 2 totally different compounds. Look at these formulas, CON versus CON3N, 2. But there's only one difference between the 2 and the names. Okay. All right, last one. I have cobalt with a 4. So this 4 is going to want to be crisscrossed down here. This 3 is going to want to be crisscrossed down here. And now I erase the charges and I smush it together like it's one thing. And there's my formula. If you guys need to, use Notability and use that annotate cut feature to actually crisscross the charges. It really, really helps. Okay. Now let's go to name it. Again, cobalt is CO. We know that the charge for cobalt is right here. It used to be a 4. That 4 got here from the charge on cobalt. So now I need a IV 4, right, to match the charge. And then I'm going to say nitrogen. But again, when you have something from the top of the periodic table in this, in this section right here, everything from this section gets changed to an IDE ending. So we'll go in here, drop that ending, and change the ending to IDE. All right, so that's our information on transition metals. I hope this helped. And I'll record another video next on polyatomics.